In this video I'm going to look at the 2014 question 3b, which is a projectiles question. So in the question we have a projectile or a particle is projected up an inclined plane with an initial speed u. The line of projection makes an angle alpha with the inclined plane. So this angle here is our alpha, and the plane is inclined at an angle of beta to the horizontal, so this angle is beta. The plane of projection is vertical and contains the line of the greatest slope. The particle is moving horizontally when it strikes the plane. So when this particle goes up here and it lands in a way that it's horizontal. Show that tan alpha equals tan beta over 1 plus 2 tan squared beta. So the first thing I always do here is I figure out my components of velocity and gravity. So what we always do is we say, well, this is our plane, so let's make our x-axis parallel to the plane which the particle has been fired up, and let's make our y-axis perpendicular to that. So first of all, let's write u in terms of our x and y. What am I looking for? Components. So ux would be u cos alpha. Uy would be u sine alpha. The next thing we want to do is make sure we get our components of g, of gravity, in those directions as well. So this would be the direction of our y component, and this would be the direction of our x component. Now this angle here will be the same as this angle here, which is beta. So this would be minus g cos beta, and this would be minus g sine beta. So the way you always start these questions really is that when the particle hits the plane, because we've made this our y line, when it hits the plane, its y distance is going to be equal to 0. It goes up, it has a y distance, and then when it comes back down, its y distance is 0. So we can say that sy equals 0. Our equation for y is ut plus a half at squared, and that equals 0 when it lands. But we need to put in our components, or our new components, for velocity and for acceleration. So our component for velocity is going to be our velocity in the y direction, which is u sine alpha t minus a half g, and what was our component in the y direction there? If we go back up, g cos beta t squared, and that equals 0. And that minus is there because gravity is working against the projectile. That means u sine alpha t equals a half g cos beta t squared. Divide both sides by t, and we can rearrange that to give us t equals 2u sine alpha all over g cos beta. And that's probably worth 5 marks, if not 10 marks, already in the question. So that doesn't really help us with getting this information here that they asked us to get, but the next bit of information that they told us that the particle is moving horizontally when it strikes the inclined plane. So when it strikes the plane, it forms an angle with the plane. And our equation for that angle is, well, the tan of that angle equals minus the velocity in the y direction all over the velocity in the x direction. Now, rather than putting in your big equation for Vy and Vx here, what I suggest you do first is you find a simplified version of what Vx and Vy are. So we know that V equals u plus at. So Vx will be our u in the x direction, which is u cos alpha, minus g in the x direction, which is g sine beta times t. We have an expression for t. We know the expression for the time it takes to land. So we can replace this t with our expression, and we'll get u cos alpha minus g sine beta times 2u sine alpha over g cos beta. The g's will cancel. We could simplify this further by writing u cos alpha minus, well, we've cos beta, sine beta divided by cos beta, so we could change that to a tan to give us 2u sine alpha tan beta. And that's all we can do with that equation so far. Sine beta divided by cos beta gives us tan beta. So we have our Vx, but we want to get a Vy equation as well. And again, I just do it here first rather than putting it straight in. I think it makes it a bit easier. So Vy, again, is u plus at. U in the y direction is u sine alpha minus g cos beta t. Let's sub in our equation for t as well. Again, that's u sine alpha minus g cos beta multiplied by 2u sine alpha over g cos beta. This one's a little bit easier because the g's will cancel and the cos betas will cancel to just give us u sine alpha minus 2u sine alpha. U sine alpha minus 2u sine alpha equals minus u sine alpha. So that's our equation for Vy. Now if we go back to our original equation, the landing angle, tan of the landing angle is minus Vy over Vx. Now by the way, if you look at this, we have alternate angles here. Hang on, I'll change the colour. If you look at this, we have a z here, which tells us that this landing angle here, I don't need to call it beta or theta, I can call it beta because it's the same as this angle here. So really I should have called that tan of beta. So tan of beta equals minus Vy over Vx. So that's going to be minus our term for Vy, which is minus u sine alpha. Now you've minus a minus gives you a plus, all over our equation for Vx, which is u cos alpha minus 2u sine alpha tan beta. Sorry, that's a little bit messy, but that's 2u sine alpha. Now we have a u in each term here, so the u's can cancel. And we'll get tan beta equals sine alpha over cos alpha minus 2 sine alpha tan beta. Now how can we simplify this further? Well, this is tricky, and you've actually got about 20 out of the 30 marks or 20 out of the 25 marks already. It's the last step is a bit tricky. So how to simplify this is actually you're going to divide, or we divide, above and below by cos alpha. And remember with a fraction, if we divide every term by the same thing, we're not actually changing the fraction, just like 4 over 2. If we divide 4 over 8, if we divide above and below by 2, we get 2 over 4. It's the same fraction, it's just written in a different way. So this will now become tan of beta equals tan of alpha over 1 minus 2. Well, sine alpha divided by cos alpha gives us tan of alpha, tan of beta. Now you might say, well, how are you supposed to know how to do that? And the thing is, there's no straight answer for that, but when you look back at the question, they want an expression that has all tans in it, tan beta, tan alpha. So when you get to this stage and you don't have tans in it, you need to either go to your formula book and see, well, can I change this to tan components? Or look and see, is there anything else that you can do? Now it's just a matter of rearranging this to get the equation that they asked for. So I'm going to multiply both sides by 1 minus 2 tan alpha tan beta to give me tan beta times 1 minus 2 tan alpha tan beta equals tan alpha. And I'm going to do this fairly quick because YouTube only lets me put up videos of a certain length. That's tan beta minus 2 tan alpha tan squared beta equals tan alpha. I'm going to bring all my terms with a tan alpha to one side because I need one tan alpha in my final equation, equals tan alpha plus 2 tan alpha tan squared beta. Tan beta equals, take out the tan alpha or factorize it, 1 plus 2 tan squared beta. And then finally divide across by 1 plus 2 tan squared beta, and we get tan alpha equals tan beta divided by 1 plus 2 tan squared beta, which is what they asked us to prove. So QED, that's what they've asked us to prove. Okay, so that's part 1. Part 2 then, hence or otherwise show that tan alpha is less than tan beta. So we want to show that tan of alpha is less than tan of beta. Well, let's have a look at tan of alpha. This is tan of alpha here. And tan of alpha includes tan beta in the term. So if we want to prove that this whole term here is less than tan beta, the bottom line must be greater than 1. And if this bottom line, the denominator, is greater than 1, then obviously this side, if tan beta is being divided by a number greater than 1, tan beta, or this side, will be smaller than tan beta. So if you look at 1 plus 2 tan squared beta, it has to be greater than 1. And it has to be greater than 1 because this is positive. And if that's positive and it's 1 plus this number, then this term has to be greater than 1. So just writing down that fact probably gets you 5 marks. If that has to be greater than 1, that means that tan of alpha, which is equal to tan of beta over 1 plus 2 tan squared beta, has to be less than tan of beta. Because if tan of beta is being divided by a number which is greater than 1, then obviously all of this must be less than tan of beta.